All right, welcome back. The third section we're going to be talking about is heat. I do want to make one correction about the last section on sound. All of the content was correct. However, I think I said that was first grade when actually the focus of the heat unit is actually first grade. The focus of the sound unit is second grade. So we are going to be talking about heat right now, and that is the focus of the first grade unit, thermal energy, and the focus of the second grade unit is actually sound. So the first misconception, as you see here on the screen, is that heat always rises. Now, the idea that heat has to rise is commonly held by students, and its sources lie in familiar phenomena such as smoke traveling upwards, rising hot air balloons, a shimmering heat haze during a summer day. However, in all of these cases, it's actually hot air that is rising. Um, Differences in density between blocks of air mean colder air will push underneath hotter air, which is the same to the process that drives convection currents. So, one of the things that we need to try to get away from saying or start saying instead is that hot air rises instead of saying that heat rises. Another misconception concerning heat is very common is the belief that if a glass of water has been left on the side for a few hours to come to room temperature and it's wrapped with insulating materials such as bubble wrap, then this causes the water to heat up. And if the bubble wrap is also at room temperature, then there's no temperature differences within the system. Therefore, no movement of heat occurs. And so the water's temperature is going to stay the same. Um, a different misconception is that if a block of ice is placed in a classroom and covered with insulating material, then it melts more quickly. And in fact, the opposite of that is true because that material insulates the ice from the warmer air temperature on the outside. So, just all of that, making sure that we address those misconceptions. So, moving on to the second one, heat and cold are scientifically different. Um, Heat is a form of energy that vibrates molecules and raises a substance's temperature. Cold, on the other hand, is a relative term to indicate that an object has a lower thermal energy than another. Um, Snow is much colder than liquid nitrogen. Both of those still have thermal energy. Both of them still have heat relative to zero. Neither of them are absent of heat. So the hotter a substance is, the more thermal energy it carries, and a cooler substance carries less thermal energy. So, some people would call it just a play on words, but heat and cold are not opposites. You could think of it as opposite ends of a spectrum of thermal energy, but not that heat and cold are opposites, just by definition. And then the last misconception is that objects that keep things warm are sources of heat. And I referenced this a little while ago when I was talking about the ice cube and covering it with something, but saying that that particular object is a source of heat is a misconception. It's the thermal insulator. It keeps heat from getting to something, but the object itself does not produce any heat on its own. And we need to make sure that students understand that those objects are not sources of heat.